Hey folks, so we've talked about systems of linear equations in two variables. And there are three ways to solve those. That was the very first section we did in this module. You can solve by graphing to find out where the lines intersect. You can solve using substitution, where you solve for one variable and you plug into the other equation. And you can solve by elimination or the addition method. Those words are used interchangeably. Then the next section, we worked on solving linear equations in three variables. So you're finding a point in space where three lines intersect each other, or possibly planes intersect each other. That's going to give you a point in space. And now we're dealing with systems of nonlinear equations in two variables. What does that mean? Well, let me just show you one. Okay, so here's an example of a system. You know, a system means we have more than one equation. What about nonlinear? What does that mean? Well, it means it's not a straight line, right? And if we have an equation that's not a straight line, that means the variable has an exponent. So if you look at the first equation, that's linear because you have x to the first, y to the first. It's definitely in two variables because it has an x and a y. But when you look at the second equation, notice that it has an x squared in it. And that's a parabola, right? And so we're not intersecting two lines. We're intersecting other shaped curves, okay? Now, how might we solve something like this? Well, this particular problem, you can solve by substitution. I could take this y value right here, x squared plus 1, and I could plug it in. That's in the second equation, and I could plug that in for y in the first equation, being careful with our signs. So that is one way to solve a system of nonlinear equations in two variables. But every system that meets those conditions, you can't necessarily solve by substitution. Let me show you another example. 4x squared minus y squared equals 4. Again, that's in two variables. Okay, we know we have a system because we have more than one equation. Hey, neither one of these guys is linear, right? Because x is squared, y is squared on both. Okay, now, this could be solved by substitution, all right, but not all of them can. But this one, because the variables match, we could do an elimination trick with this one. So this problem could be solved by using the addition method or the elimination method. So we're going to solve some by substitution, some by elimination, whatever works the best. Some you could solve both ways. Okay, so just keep that in mind, and I want you to do what's most practical. So what I want to do first, I think, is we're going to go back to this very first system of nonlinear equations in two variables that I have listed and actually solve that problem. So x minus y equals -1 and y equals x squared plus 1. So again, the idea, because we have y equals, we're going to take this, what y equals, and plug it in for that y value right there in the first equation. So let's write that down. You go ahead and get started. I'll catch up. So we have x, and then we have minus y, which is defined to be x squared plus 1, is equal to -1. So notice I substituted the second pink into that y value right there. Everything else stays the same. The x and the -1 are still there. Now we just need to solve this equation because if you'll notice, it only has one variable in it, just x's. That's it. So let's simplify this thing a little bit by distributing this minus sign inside. So this minus needs to go inside with each term. That's going to give me x minus x squared. Then negative times this positive 1 is going to be -1 equals -1. Okay, now most of you are used to looking at quadratic equations. That's what this is, right? The highest power is an x squared in descending order. So I have -x squared, just moving that guy in the front. This is positive x minus 1 equals -1. That looks a little bit better. But you know what? Every time we solve a quadratic equation, we get it equal to 0, right? Now I say every time, not really. Sometimes when you just have x squared and a number or a constant, you can use the square root property. But if you have an x squared and an x term, folks, you need to get that equal to 0. So how am I going to do that? Well, I'm just going to add 1 to both sides of the equation. Can I do that? Sure. That's a property of equality, right? You can add the same number on both sides of an equation. So that gives me negative x squared plus x. Hey, this negative 1 cancel out. So that equals 0. These do too, which was the point. Now we can solve this equation. Now, how do you solve quadratic equations? Well, you've got the square root property, but that's not going to work here because we have an x squared and an x term. You've got factoring at your disposal. Will factoring work here? Sure will, right? Because you've got a greatest common factor of x. And if it helps me. Whenever that x squared is negative, let's pull out a negative. So there's an x in common, and I'm going to pull out a negative x. It's going to leave me with x minus 1 equals 0. Does that feel okay? Multiply it back inside and make sure that we get what we have over here. So negative x times x is negative x squared. Yep. Negative x times negative 1 is plus x. Still equals 0. Yes. Now this is completely factored. So what do? I set each factor separately equal to 0, and I solve for x. Now to solve this first one, I divide both sides by negative 1, which seems kind of silly because that gives me x is equal to 0 still. 0 divided by negative 1 is 0. That is one of my solutions. I'm going to circle it, not that I'm finished. I'm not. Add 1 to both sides here, and I get x is equal to positive 1. Now we're not used to having two different x values. Is that okay? Sure is, and that's going to happen when you're dealing with nonlinear equations. But don't forget, you're solving a system. And a system of two variables is a set of ordered pairs. So the correct answer is going to be an x and a y value. Don't copy that. That's supposed to be 1, right? So x is equal to 1, but I don't know the y value. How am I going to find that y value? I'm going to change colors on you. And size of the pen because it just seems too big. There we go. And I'm going to plug in x equals 0. Where? Doesn't matter, y'all. You can work with the first equation or the second equation. I'm going to work with the first one. So we have 0 minus y is equal to negative 1. 0 minus y is equal to negative 1. I divide both sides by negative 1 to get y is equal to 1. So one of my solutions is 0, 1. What's the other one? I'm going to take 1 and plug it into the first equation. You got 1 minus y is equal to negative 1. Again, I'm trying to get this y by itself, so I'm going to subtract 1 from both sides of this equation. It's going to give me negative y is equal to negative 2. I divide both sides by negative 1 to get y is equal to 2. So there we go. These are my two solutions. If I type that in the system, I'd put a comma between them. How do I check them? I take both of them separately and plug them into both systems. So 0 minus 1 is negative 1. That's correct. And then 1 is equal to 0 squared plus 1. That's correct. Check this one. Now I'm going to go 1, 2. So 1 for x minus 2 for y is negative 1. That checks out. And then 2 is equal to 1 squared plus 1. That is true too. So I have checked both of these. Notice I did this quickly in my head. That's because I'm trying to save space. But you should do them on paper if you really care about what you're doing here and when you want to get this done. I'm just trying not to bore you to tears and knock these problems out. So let's try another one. You want to? Now, substitution, right? How about, it's time, y'all. How about you pause this video and you substitute and see if you can solve this equation. And then just, if you feel pretty good about it, fast forward all my talking, get right to the solution, see if you got it right, and then move on to the next problem. How'd it go? Did you figure it out? Or did you figure out where your questions are? If nothing else. So here we go. I'm going to substitute because this is already y equals. I'm going to take this entire y value right here, trying to circle it, and plug it in right there for that y value. So that gives me x squared plus 2x minus 1. And on the right, I've got x squared plus 4x plus 5. Okay, now I need to solve this equation. Now, it's a quadratic, right? How do I know it's quadratic? Because it's got an x squared in it. So we already know the best thing to do is to get these guys equal to 0. So the first thing I'm going to do is subtract x squared from both sides of this equation. Right? And when I do that, those cancel and those cancel. Okay, that's kind of convenient, isn't it? And then it gives me 2x minus 1 is equal to 4x plus 5. Now I got to get, now do I have to get this equal to 0 anymore? Well, actually, no, I don't, because my x squared's canceled on both sides. Now I have a linear equation, and I just need to get all my x's on one side and my non-x's on the other. So I'm going to subtract 2x from both sides of this equation. That cancels. I got negative 1. 4x minus 2x is 2x plus 5. Now what am I going to do? Solve for x, right? So you know the drill. Subtract 5 from both sides. So you got negative 6 is equal to 2x. Well, now what? Divide both sides by 2? Yep. X is negative 3. This time I only got one solution. Now that's not my answer, because my answer is an ordered pair. Whenever you have an equation in two variables, your answer is an x comma y. I have x. How am I going to find y? Your choice. You take that negative 3 and plug it in either of these two initial equations that are in our system. So I'm going to just go with the first one. Y is equal to negative 3 squared. Hey, notice those parentheses and the square on the outside. You have got to square the negative and the 3. So if you're thinking that's negative 9, negative 3 squared is positive 9. Calculator, you must enter those parentheses also if you're calculator dependent. 4 times negative 3 is negative 12 plus 5. I'm working this guy left to right. 9 subtract 12 is negative 3 plus 5 is 2. So my y value is 2. So my answer to this, in other words, these two parabolas intersect each other at one point. Negative 3, 2. And that's it. Okay? How can you check it? You take negative 3 for x and 2 for y and plug it in. So I'm going with the first one. Negative 3 squared is 9. That's going to be minus 8, which is 1. Is that right? Negative 3 squared is 9. And then, oh, yeah, minus 12. Let me try that again. 9 minus 12 is negative 3. Negative 3 plus 5 is 2. Does that equal to y over here, 2? Sure does. When I did the check to start with, I multiplied wrong, didn't I? Let's do the second one. Negative 3 squared is 9 again, plus a negative 6. So that's going to be 3. 3 minus 1 is 2. Does that equal to y over here, 2? Sure does. So we have checked this as well. Okay? Let's try another one. Notice it says just solve the following system of equations. If we can do this by substitution, we will. If we can't, we won't. Okay? Can we do this by substitution? I know we can't do it by elimination. We haven't done one by elimination yet, but there's no way I can cancel an x with another x term because this doesn't have an x term, or a y with another y term. Why? Because this has just got an xy. That's multiplication right there, y'all. So whenever you have multiplication in one of them and not in the other one, you're going to have to use substitution, and you're going to have to solve for either x or y. Your pick, it doesn't matter. So I'm going to go with this first equation. Okay, xy is equal to negative 12, and I'm going to solve for x just because it's listed first. There's no special reason, so I'm going to divide both sides by y to do this job. Okay, what does that tell me? X is equal to negative 12 over y. And I'm going to take that value and substitute that in for that x right there. Really? Yes. Okay, so I'm going to remove that x, and I'm going to replace it with negative 12 over y minus 2y plus 14 equals 0. Okay? Now, we all know that you don't want to solve an equation with a variable living in the denominator. Does that mean we just can't do it? No. That means you want to what we call clear fractions. Let's multiply both sides of this equation by y to get that y out of the denominator. If you need to see that happen, I will write every step. So you have y times negative 12 over y, and you have minus y times 2y plus y times 14 equals y times 0. I put that y in front of every one of these terms on the left and on the right. Now, why did I do that? These y's cancel, and I get negative 12. This negative y times 2y is minus 2y squared. And this y times this 14 is plus 14y is equal to y times 0 is 0. Folks, we have ourselves a quadratic equation, right? Got a square in it. Now, one thing about quadratic equations, we like to write them in descending order. Another thing about quadratic equations, it always feels a little better when the square term is positive. So y'all don't mind, let me just move every one of these terms to the other side. So if I take minus 2y squared and I move it over here, it's going to make it a positive 2y squared. If I take this 14y and move it over here, it's going to make it a minus 14y. And if I take this minus 12 and move it over here, it's going to make it a plus 12. And there's still going to be 0 on the other side. So I'll switch sides on you. Another way to think about that, and this is probably much easier. Why didn't I explain it this way? I don't know. I just didn't. Multiply everything by -1. And then it's the same idea as moving everything to the other side of the equation. Now, to make your factoring life easier, does it even factor? I don't know. But I do see that there's a 2 common to all 3 of those terms. Hey, let's pull it out, because that's going to make the factoring step much easier. I divided every one of those dudes by 2. And it's sitting out front. It did not go away. Now I'm looking at numbers that multiply to be 6 and add to be -7. Sure, we can do that. That'd be y minus 6 times y minus 1 equals 0. You're not fond of that? Use the quadratic formula. It's your best friend, right? It's just not as fast as what I just did. Matter of fact, it takes up a lot of space too. So if I can factor, I tend to try to factor. And that does factor. Now what do? I set each of these 3 factors equal to 0. Well, when you set 2 equal to 0, there's no variable there, so I don't get a solution for that. But I do set y minus 6 equals 0 and y minus 1 equals 0, and I get y is equal to 6 and y is equal to 1. I'm going to circle it so I can find it. But now that's not my answer, right? Remember, my answer for a system of equations in 2 variables is a set of ordered pairs. I'm going to change colors on you. I'm going to go red to get all this to fit. And let's go to the right. If y is equal to 6, how do I find x? Because my answer is going to be something 6. So I take that 6. How about we plug it in the first equation over here? xy equals -12. What do I multiply by 6 to get -12? -2, right? Or plug it in. Just trust me. So x times 6 is equal to -12. I divide both sides by 6, and I get x is equal to -2. That's where that came from. Okay? All right, now what about the other one? So this is one of our answers. Now the other answer is when y is equal to 1. I'm going to move bottom. I know this is completely disorganized, but I don't want to open a new page. So y equals 1. What am I going to do with that? I'm going to plug 1 in for that y right there. So x times 1 is equal to -12. Well, x times 1 is x is equal to -12. Look at there. There's my answer. So x is -12, y is 1. That's the other solution. Now, y'all don't enter this in the system, especially a test, without checking the other equation. So I'm going to take my x is -2, y is 6, and plug it in the second equation. So if I got -2 minus 2 times 6, so it's -2 minus 12 is -14. Plus 14 is 0. That one checks. Now take -12, 1 and plug it in that second equation. So -12 minus 2 times 1, which is -12 minus 2 is -14, plus 14 is 0. Yes, they both check. You see how easy this is? You can do this. I know you can. Let's try another problem. Maybe one more and then pause it and come back for part 2. Does that seem reasonable? All right, so let's solve this system. How about we just go ahead and pause it? Because, you know what? This system, you really probably don't want to do substitution. I think elimination is easier, and that's a good break. So let's come back for part 2. If you're full on, go ahead and click on part 2. If you need a break, take a break, and then come back for part 2. Y'all have a good one.